Good afternoon, everyone. Welcome back to AI Engineering, presented by Nehemiah STEM Research. My name is Moise Donald, and today we will be picking up where we left off last week with machine learning ops via Fast API, and we'll be moving on to Flask, but I'd like to first pick up where we stopped last week because we didn't manage to run our server because of an error. And just to explain, the error was in the name of our file where our Fast API server is set up. Now this file was actually named as, let me just show you here. So this is how it was named last week, so that was what was causing the error. So I rectified that, and yeah, so we fixed the file name issue, and now when we run our app, you can see that the server is going to start and run successfully. Yeah, you can see application startup complete, and our model is also loaded successfully. And then we can now test our URLs. So if I go to my browser, well, let me make sure I can share that screen. Okay. So first of all, the API route is at localhost port 8000, right? So we need to test that and see if it's running in our browser. So do HTTP, no, not YouTube. And it's local host 8000. If I run this, yeah, you can see it's echoing the message iris classification API version 1, and then these are endpoints that we can use to test. There's doc, there's health, there's predict, there's batch predict, and yeah. So if I put docs here, you should see the Fast API documentation, and it's here. So this is the health check. This is the predict. This is the patch predict. Yeah, so that is Fast API. Maybe you just want to see each one. It's healthy. Yeah, so now we can move on to what we're covering today, which is introduction to Flask. Let me close this. And could start by defining what Flask is. So Flask is a lightweight WSGI web application framework in Python. It's designed to make getting started quick and easy with the ability to scale up to complex applications. Now, WSGI stands for Web Server Gateway Interface. It is a specification and standard interface that defines how web servers communicate with Python web applications or frameworks. So WSGI acts as a bridge between the web server, such as Apache, Nginx, or others, and the Python application, allowing them to work together smoothly. We can look at some key differences between Flask and Fast API. And with Fast API, you have asynchronous support, but with Flask, it's native. So there's async await, sorry, and So with Fast API, the async support is native, which is async or await, and with Flask, it requires extensions. Then with the data validation feature, with Fast API, it's built in with Pydantic. With Flask, it's manual or with extensions. The documentation with Fast API is automatic. That could be with OpenAPI or Swagger, and then with Flask it's manual or with extensions. Then performance ratings, Fast API is very fast. Flask, it has a good performance, but it's not as fast as Fast API. Hence the name Fast API. And then for the learning curve, Fast API it's moderate, Flask is easier. In the ecosystem, Fast API is growing rapidly, and with Flask, it's more mature and extensive. So why learn both? Fast API, again, modern high-performance APIs with automatic documentations or docs, and then Flask is flexible, has an extensive ecosystem, and it's great for web applications with user interface. So those are some of the key differences between Fast API and Flask. So like I said, today we're looking at Flask, and let me close this server. Yeah, so when you're looking at, when I update the repo, when I push this, you'll see there's a new directory called MLOps Flask. in the main directory. So this is where I've set up the file. Of our Flask machine learning API application. Now, because of time, I don't want to take all the time in the lesson or the tutorial typing all this code, but I'll break it down line by line. Yeah, so when you open this, you'll see there's a templates folder, there's a static folder, and then models, and then we have our main Flask file or our main app here, and then of course the requirements file with all the libraries that are needed. There's Flask, NumPy, scikit-learn, and joblib. I'll explain why we added these at the end, but let's go through this. So of course the imports from Flask, and import Flask, request, JSONify, render template, import NumPy as NP, import joblib, import logging handlers, rotating file handler, OS datetime. So for the first line 1 from Flask, so it imports the Flask web framework package, Flask, which is main Flask class to create web application instance. Request is the object containing all incoming request data, that is the JSON form data, the headers. Then JSONify is a function to convert Python dictionaries to JSON responses with proper headers. Then render template is the function to render HTML templates with dynamic data. And then of course you remember that NumPy is the numeric computing library for array operations and math functions. Line 3, joblib is the library for saving or loading Python objects, especially machine learning models. And then logging, which is from logging handlers, and import rotating file handler. So import logging, that's Python's built-in logging system for tracking application events. And then from logging handlers, import rotating file handler, that's a special handler that creates log file backups when size limit is reached. And then those last two, import OS from, and then from datetime, import datetime. So import OS is the operating system interface for file directory operations. And then datetime is for getting the current date or time for timestamps. Then of course after that we start the application setup and configuration. Then line 14 we have app is equal to Flask, then name. App is the variable that holds the Flask application instance, and then Flask, and then you have in brackets name, it creates a new Flask application. The underscore name here in the brackets is a special Python variable that equals basically main if the file is run directly. The module name if imported elsewhere. So its purpose is that it tells Flask where to find templates and static files. And from line 17 to 18, we'll start with this. Marvin, do you have headsets? Do you have headsets? Headsets. Yeah, like there's it's a bit distracting hearing myself when I'm talking. Yeah, so saying this line here. So app config is the dictionary-like object for Flask configuration, and then JSON sort keys is the configuration option for JSON response formatting. Then it being equal to false prevents automatic sorting of dictionary keys in JSON responses. Why? It maintains consistent key order in API responses. Then line 18, app.config max content length is equal to 16 times 1024 times 1024. The max content length limits maximum request size, and then this calculates 16 megabytes basically. Its purpose is to prevent memory exhaustion from large file uploads. Then the third section, which is login configuration, line 25 to 26. So here this checks if the logs directory exists. Then if it doesn't, it creates the logs directory. So that's what's happening here. It checks if the logs directory exists. If it doesn't, it creates it. The purpose is to ensure a log directory exists before configuring login, which is basically the next part here. So from line 29, (36). Parameter breakdown, we have level is equal to logging info. So only log messages of info level and above, that is info, warning, error, critical. Format is equal to, basically line 31. Defines the log message structure. This is the timestamp. This is the log level, which could be info, error, etc. And then this is the logger name. This is the file name and line number. And then this is the actual log message. And then we have the handlers configuration. So we have line 33, rotating file handler, backup count. Now this part here is the log file path, and max bytes 1 million, yeah, is basically 1 MB maximum file size before rotation. Backup count is equal to 10. It keeps 10 backup files when rotating. And then this is also output logs to console. So it outputs logs to the console. And then line 38, logger is equal to login get logger. So it creates a named logger instance for this specific module. Name ensures the logger name matches the module name. The benefit is that it can configure different log levels for different modules. Then we have another section here, global variables and model management. Model is equal to none. Model version Flask version 2. Class name Setosa classic color. So the model version v2.0 tracks which version of model is deployed. The class names maps numeric predictions 0, 1, 2 to human readable names. And then we define the load or train model. So line 49 here is a function to handle model loading. And then global model allows the function to modify the global model variable. We have a try instance here. It's a error handling block. So it's the start of the error handling block. Model job lib.load is an attempt to load the saved model. Logger info, that's line 58, is a success message logged with a check mark emoji basically. Then return true indicates the model was loaded successfully. Then except file not found error. So this is the handle case to handle the error in case the model file doesn't exist. Say logger warning no pretrained model found using rule-based classifier. Then of course delete return false which indicates using the fallback method. Then we have another section here, error handlers. So from line 70 to 78. Is a decorator. So this part here, if you remember from last week or the previous lesson, is a Flask decorator. Instead of a first API decorator, it's a Flask decorator that registers function as handler for 404 errors. So when triggered, like let's say when a user requests a non-existent endpoint, it will be triggered. Can try and break down the function itself. Define not found error is the function that handles the error. Error is the exception object passed by Flask. Logger warning 44 request. It logs the invalid URL. Return JSONify. 404. It returns a JSON response with a 404 status code. Request the URL. The URL was requested but not found. Then we have another error handler after that for the 500 status code. So error handler 500. So just like the previous one was for 404, this one is for 500. So it handles server-side errors, which is basically exceptions in code. And then this is to log at error level, or it's basically a more severe than warning. This converts the exception to readable string. So this is string and then error. Same here. This is for the error type 400 or status code 400. So this one is to handle malformed client requests. So let's say the client sent invalid data that the server can't process. And then we have another section for utility functions. Define, validate features, data. I'll explain this section. So it's validation logic. So required fields is a list of fields that must be present in the request. For field in required fields is a for loop through each required field. And then if field not in data, return. So it's an if statement, so it's to check if the field is missing from the request data, and then return false. Then F, this is a string missing required field, so it returns failure with a specific error message, which is this: missing required field. And then there's an error handling here, try. So it's an attempt to convert values to floats. Yeah, try this part here is an attempt to convert the values to floats. Float data, sepal length, convert string to numeric float. Why? It ensures the numerical operations will work later. And then from line 1, 24 to 21, 25 is a range validation based on the iris dataset characteristics. So this is basically to prevent unrealistic values that break the model. Each feature has biologically plausible range. And then line 133, except value error type return false. All features must be numeric values. So value error is raised when the string can't be converted to float, and then type error is raised when wrong data is provided. So this here is to catch non-numeric input and returns a helpful error, which is this. So all this will be logged into the terminal in case all that happens. And then from line 138, here we're extracting individual features from in the input dictionary. Just to note, this is a simplified rule-based classifier for demonstration. If, else if, again rule-based classification. Setosa flowers have small petals with the length not more than 2.5 centimeters. And a width of not less, Setosa flowers have small petals, a length less than 2.5 centimeters and a width less than 1 centimeter. Then versicolor has medium petals, a length of less than 5 centimeters and a width of less than 1.8. Then virginica has large petals, including everything else. And then these are the confidence values to simulate the model certainty. Now you're probably wondering what are those Setosa things. That's from here. These are the class names from what we're pulling from the iris dataset. Yeah, and then this line here, confidence, is equal to max line 160. It's to generate a random number between 0.0 and 1. 0.1 to 0.5 being the scale to range, and then the confidence adds a small random variation to the confidence. This part here, confidence plus, adds a small random variation to confidence. This is the scale to range. This is the clamp confidence between 0.7 and 0.99. Its purpose is to make the demo more realistic with varying confidence scores. And then it first returns the prediction value and the confidence value. So after that we have the section for the routes and API endpoints. So just like last week, this maps the function to the root URL. Define index is the function called when the user visits the root URL. Logger.info is a log that the home page was accessed. Render template returns the HTML template with variables. Now that's where this is. Here, this file, so it's going to return this. And then of course the model version and then the timestamp. So it will pass the version to the template, model version, and then pass the current time to the template as well. Then from line 176 to 190 we have API route. So this is the API discovery endpoint. There's a date time now. Yeah, it's the standard ISO format timestamp. So it returns the API information and available endpoints, which are health, predict, just like the first API. we're looking at last week. Then this is the health check route, the API health check route. This is the predict. Let me just go back to the health. Model loaded. We got the model is not none, so it checks if the machine learning model is loaded. Of course, the methods. It's a get method, so it only responds to get requests. Status, got healthy, model loaded, else degraded. So if the model is loaded, it's healthy. If it's not, it returns degraded, which is ternary condition. Yeah. So this is monitoring systems to check if the API is operational, and then returns comprehensive health status information. That's what this is doing. And then we have the single prediction route. So the method is post, so it only accepts post requests, and then this logger.info logs that the prediction request was received, and then if statement here, if not request is .json, it checks if the request contains JSON data, and then returns a 400 error or 400 status code error if it's not JSON, with a descriptive message, which is content type must be application or JSON. And then data is equal to request dot get JSON. This part here passes JSON data from the request body into Python dictionary, and here it calls the validation function and then returns a 400 error message with specific validation failure message, which is invalid input data. And then it tries to catch that. Let's start with just here. So this gets the prediction result, and this gets the prediction result. This converts the number to a name, and then this logs the successful prediction with a confidence score. And then this returns a structured prediction response, of course in the JSON format. So there's prediction, predicted class, confidence, mode version, and a timestamp. This here is to round to the decimal 3 places for cleaner output, but maybe you just want to know that. And from line 251, accept exception as E. So this is to catch any unexpected errors during prediction, and then return the 500 internal server error with details. And then this is the batch prediction route. So similar to the single, which we just looked at, the single prediction, but this one handles multiple samples. Then if not, request is JSON. So ensures the input is a list and not a single object. And then here, this is a, so this ensures the input is a list and not a single object. So this is to prevent processing zero samples. That's what this if statement are for. And then it has a size limit to prevent resource exhaustion. 100 samples maximum. And then results is equal to errors for I. Yeah. So results here stores successful predictions, errors stores validation failures. Then here we have a loop, a for loop, enumerate data. This is a loop through the samples with index, and then continue. Skip to next sample if the validation fails. Then we have the try. So this is meant to process each sample individually, and then also store original features in response for traceability, and then catch individual sample failures without stopping the entire batch. Then we have a logger here to log the batch completion statistics, and then return a comprehensive batch results with success or failure counts. And we have the last route here, which is the model information route. It's also a get method, so it only responds to get requests. So its purpose is for the API clients to discover model capabilities, and this part here, type model name, is to get the actual class name if the model loaded, and then returns model metadata and supported features. So all that was configuration. All that was configuration, and then we have the last section, which is the application startup. So we have app before first request. So it's a Flask decorator which runs before the first HTTP request. Its purpose is to perform setup tasks before serving requests. And then it loads the model, so it's ready when its first prediction request arrives. And we have if name main. Yeah. So this part here will only run if the file executed directly or is not imported. OS make directories or make directory. So it creates directories and then ignores if it already exists. And then load or train model. So load the model immediately when starting the development server. And then this part here is the server configuration. So host So it listens on all network interfaces and is accessible from other computers. Port 5000, uses port 5000, this is the default Flask port 5000. Debug is equal to true. It's to enable debug mode, auto reload on code changes or detailed error pages. Threaded true is to handle multiple requests simultaneously. So in summary, the main purpose of this file is to create a production ready Flask web API for machine learning models serving with RESTful endpoints for predictions, comprehensive error handling and logging, input validation and data sanitization, health monitoring capabilities, web interface for easy testing, and batch processing support. It has some key features like professional logging, file and console logging with rotation, error handling, that's custom JSON error responses for all common HTTP errors, input validation, that's type checking, range validation, required field checking, model management, that's load persistent models with fallback behavior, and then API documentation, self-documenting endpoints with model info. Another key feature is monitoring. It's ready to be monitored, so health checks for deployment environments, and then security. It requests size limits and input sanitization. So I wanted to also to explain why we have an HTML file here, then of course okay, I forgot to create the CSS file because that's where it's pulling from. Okay. So why it's there is basically to give it serves as the user interface for machine learning API. While APIs are great for programmatic access, many users, especially non-tech savvy ones, prefer a visual interface. So that's why we create that HTML file, index.html. Yeah, that's it. So maybe the benefits of having a web interface, so it's user friendly for testing, so non-technical users can test the model. And then API demonstration shows how to use the API endpoints, rapid prototyping, quick feedback during development, and then accessibility. It's available to users who don't know how to use like Carl or Postman. So let's try and run this. Okay, so I had to remove the decorator since I was typing it in an outdated version. But yeah, the Flask app is now running. Let me expand this terminal. Warnings and errors. The pre-trained model. Let's see. Oh, yeah, because you're not able to see the screen until I share. Let me copy this. Yeah, so this is our Flask app. These are our endpoints. If we predict, we have class Atosa, confidence. Yeah, so that's working well. So what you're seeing here is all in the basically what we designed in our HTML file. Let me share that screen. Okay, I need to minimize this first. Yeah. If you're familiar with HTML, so what you're seeing there on the Chrome window is all here. So yeah, that is Flask API, Flask API server tutorial with machine learning. Thank you for tuning in. Don't forget to like the video, subscribe to the channel, and leave a comment. Thank you.